Hey, to whoever is watching this video, I'm really glad to introduce you to our final project for ICDS. My name is Sam, and I worked on this project together with Jacob and Leon. Okay, so let's get started. All right. So our key motivations behind it is first secure. Privacy matters, and every year a lot of families suffer from identity theft and catfishing. To improve that, we have included a login password system and also the encryption, where the messages between the users are encrypted and decoded between them, and no one else could know what happened. The second one is a minimalist style. We reorganized the majority of the previous GUI systems to strive for a better GUI. We make it more cleaner, more compact, and hopefully better. But judge it for yourself. And the third one, user friendly. User friendly basically means the accessibility. We hope our GUI system could be more accessible to people. We include a CNN based handwriting recognition pad where the users could hover his mouse to the canvas and write down the alphabet letters, it will recognize for you, and it's easier for your input for some users who don't really want to type. And the last one is fun and engaging. So in this master's ICDS lectures or recitations or more kind of focus on the problem solvings in some given settings. But this one's give us a lot of freedom to explore the opportunities and like for like computer science and creative codings and a lot of fascinating features. So we really enjoy it, and I hope that you can also enjoy it. So we include a lot more exciting features, Easter eggs. Keep your eyes open. So let's get started. Demo time. First is the login system of our program. So here we are. So this is the login panel. So now I haven't logged in anything, so there should be no users have been activated. Use your username. So let's try it out. So let's type, for instance, let's type someone's who's never happened before, which is me. I haven't registered. Random password. Are you retarded? No, I'm not. I just simply forgot to register. So now I'm going to register this new account, and I'll call me Sam. This is who I am, and registration successful, and I can log in. So now I log in, but I've input the wrong password. Are you retarded? No. Because I forgot the password. The password's 123. It's very simple. And after I log in, it gave me accessible, granted me accessible to this official chatbot system. Okay, so now I'm trying to log in another users, but now my Sam account is still live. So let's try if we input Sam again. The user is already logged in. It blocked me from logging multiple times. It is a very secure strategy, especially in case someone's stealing your account. They cannot log in when you're logged in. So that's one way to protect your security. So let's register a new guy. So first, I'll also show you if you registered the already existed account. You'll see username already existed. This prevents for catfishing. For example, if someone have the want to be like you and they will steal your name, and they might probably fail because um, only one username is allowed uh, in this. Oh, Leon's already tested before. I forgot. Leon 1 then. Okay, so I have named myself Leon 1, and I logged in. So, oh, wait, what is my password? I forgot my password. Okay, quickly. Doing another Jacob. Jacob. 123. Okay, so now I'm logging to Jacob 123. So voila, Jacob is also logged in. Let's go to another part. The second key feature is the better GUI. So let me walk you through this. as you can see, we're already logged in, and I have separated the two GUI panels into two different windows that can better for convenient use later. So you can see it actually could be stretched, and pretty easily. And you can see there is originally nothing on the panel. It's empty. The chat box is empty. To make it more simplistic, minimalist, and more beautiful. So I deliberately choose the blue and orange stripes because that's kind of my favorite colors. So if we want to get started, we need to type get info pages. But if you don't want to press the get info page, you just randomly type anything. For example, in sim, type in anything, it will pop out. It will tell you what to do. So now Jacob want to link to sim, so we need to type in C sim, and we just press the send button, and we are already successfully connected. So as you can see, there are various buttons here. Those are pretty good. So in a very brief conclusion, compared to the previous GUI sample, which is more crappy and small, and you're not able to drag or zoom out or zoom in, make it bigger or smaller, our GUI are more adaptable and flexible in terms of that. And you can see there are various buttons, but that will be leave for the more exciting feature later. So wait for it. So let's go to another one. Another very important thing in our project is about encryption. And since encryption is not something that can be shown and on the interface, so we will integrate the encryption part and the analysis for Leon to bring out. So welcome, Leon.
Explain how this encryption decryption thing works. So the first thing we did is to import these four libraries. The first one, the random one, is used for generating the private keys, and the hash library is used to hash the shared secret into a usable AES key, which is for the purpose of further information transition. And the third one is the AES-GCM, is from the cryptography to just give the secured encryption. And the fourth one, the base 64, just allows us to encode it into easy data for like transmission. And yeah, here is what we use to generate a private key. Before that, we use the recommended parameters, which is the a long prime number with the bit length of 2048. And this is because it's too long, so we just use the to shift it into the standard ones. And yeah, that's how we do it. And then we generate the private key and the public keys. For the private keys, we just put a random number between these between 2 and here, the large prime number -2 to make sure that it is usable. And for the public keys, we just use the standard method to calculate it. So basically, we just compute as a g to the power of private key and mod p, and that is how we use it. And then we just generate the shared secret. So how we compute the shared secret is to still the standard process. And this is what should be looked at, is the way we change the AES key, like we derive the AES key from the shared secret. So how we do it is like by default we ask it to be a 32 byte, which is like 256 bits. And for the AES 256 encryption, but I can also change that using 16 and to 128 encryption. And the lower is the actually AES encryption process, which is just imported from the library. And this associated data is an optional metadata. It is just for, it's not encrypted, but for to check. It's for the purpose of checking of the whether this is a pure message or not. And this nonce here, the nonce here is also a randomly generated one, and it's just unique. And the decryption process is here, so it's just basically doing the reverted ways. And the step 7 we have here is the encode. So why we encode it is because we want to, like, for the transmission via the here the server or like even the network. So we have to use the nonce with the topper one and encode it using the base of 64, which is upper, like what we imported in the very beginning. And again, the decoder is doing the other way around. So we just wrap it into the encrypted to like 64. That's how we do it. And yeah, this is just I'll say for the encrypt to base 64 and decrypt from base 64 is more of a user friendly thing. So we just converting the strings into the bytes, and so you can encrypting the plain text and just returning encoded like string, which is just I'll say that is more of the user friendly purposes. So to sum up, basically this is we first use a key exchange, then we just use the AES-GCM method to encrypt the data, and then we just encoded it for easy transmission purposes, and that's all.
Another very important thing in our project is the writing pad. This is a hand recognition system coded on the basis of the CNN network and the datasets. I put a lot of efforts into it. So after I already connected Jacob to Sam, I could freely send any message, and assume that I don't want to type. I can use this pad as handwriting system. So this could be dragged, but I will not tell you yet why this dragging is for. There's an Eastern egg spoiler alert. So you can simply just input any letter you want. Though there's chance that it might be inaccurate, but as long as you try more times, it will work. So for example, let's put a Q here. Look, 99% chance this is a Q. I'm doing pretty good here. This is a perfect Q. So this is a Q. Let me to do is a like T. Okay, so now this happens. In the writing path thing, it might be in an R, but it is actually a small letter T. And you can see the small letter T is actually here. So the reason why I'm having 10 different possibilities using the softmax is just for because sometimes a letter could be similar to a lot of different letters. So this really helps the users to choose which letter they want the most, which is also something we see pretty common in WeChat in China. So let's implement this T. So there are more interesting features about this. How about oops, it seems like you're already seeing a little Easter egg. So every time you input something, there's 10% the chance there's the same as smart gonna pop up. So yeah, I'm smart. If you click it, it will get you an S. S is for super. So let's do this again. So now we have a 9, and you can see at least 7 and 9. So it works. So that is a basic demonstration for this. But I think I will not come back in more features then after I finished doing it. So I just show you the Easter egg is. So as you can see here, look, my face. If you drag the window to the far right bottom corner, you can see my photo. This is me working with my ICDS final project. I hope you enjoyed this mini Easter egg. So after that, you can send it, and yeah, it's basically what is the writing path for. Great. So after seeing all these elements like keypads, encryptions, and better GUI, I bet you are thrilled to see other key features, which are quite obvious to be honest. So I'll walk you through that. Still in the same interface, but this time I'll use only one. Maybe the same one, the same, which is me. So here, this looks unclearer. So there's 3 emoji buttons here. The first one is a poop emoji. According to a unknown study, which is not real, people really enjoy using poop emoji, which is one of the most common emojis, second to the eggplant emoji in the world. So the second emoji I chose is a unicorn. Unicorn is also commonly used in the people who love unicorns, which is me. Apparently, I love enjoying watching My Little Pony, the magic of friendship. I love it. And the third button you see is a squished turtle long bar. So you can see actually there's 6 turtles here. I was trying to show that the turtles are chasing each other, but somehow the turtles are too small and it doesn't show it off. So it's a turtle bar, and it will get you a turtle once you press it. So these are the key emojis, and having fun using them. So after the emoji part that we integrated, there's also this flash button. Flash button is shocking. So let's see what happened if you press it. Wow, everything is flashing. So basically how I make it possible is using the color contraster. So every time, every maybe a 0.2 second, the entire interface colors will be shifted contrastedly, reversely. It won't stop until you press the flash button again. Let's press it. Wait, okay. So now it restores to normal. I hope you enjoy this key feature. It takes me really long to materialize it, but I really like it. So I think there's one more buttons left I haven't introduced, which is the decoration button. Saying sense very handsome. This literally is my watermark for this GUI. So if you're curious, I won't be pressing it for right now, but feel free to press it. I'm just leaving some suspense. You can run it on my own program and see what will happen. Now let's heading towards the analysis part. As Leon has already analysis the encryption part, I will doing more focus on my part, which is the CNN, which is one of the oops, the most important feature of our project. So this is the first code I'm using to generate the trained data set or model to be more specifically for the handwriting recognition process. So this one is basically I followed an online YouTube tutorial who teach me how to set up a basic letter and digit recognizer. But this is not very accurate, and to be honest, it's not accurate at all. Everything you input will always turn out in I or a J for some reason. And you see there's only 2 hidden layers in the recognition network, so this is really low effective. And after this being loaded, the entire code being loaded, this will be saved as a new model, and the new model will be later and trained, and later it's not being trained, but being prepared for the pad, which is calling this function, calling this data or the model set to recognize the handwriting. However, this is a very good, better one. Though I also having taken a lot of insights from the GitHub tutorials, but this one's much better. You can see it's actually using a lot of key features in the key models on like the max pooling 2D, convolution 2Ds, with the kernel size is like just the 3 times three, right? So they have a lot more models, and the mods the training become more effective, and the accuracy actually bounced from like only 10% to about 50%. Though this is still quite low, but I'm quite satisfied with it. So the APOD just means the times each time the data has been refined. So the 20 is pretty much a good ballpark point where it stops being better. It converges to a certain accuracy. So after implementing these two, especially after having these two, it's going to be saved as smart sync curves, and this will be later utilized in the path system, where it's most about the GUI functions and the button press and then the paintings and for recognitions. So after all these recognition things happened here, let me see. Uh, I have this specifically designed for having more prediction solution. So this basically help you predict the top 10 possible outcomes for the handwriting. Because I know that the recognition rate is low, so I specifically add this so that even the recognition accuracy is low, there's still more chances that it gets to the right one. So this is my part.
And so finally, we have reached our discussion part, discussing about our reflection on our project and how we can improve it in the future. So the main problem we have spotted mainly include password encryption, CN accuracy, and also GUI perfection. Well, in this project, we have successfully implemented the encryption of chat between users. Many people might neglect is the encryption of password. As you can see in the program shown on the PowerPoint, the way we encrypt the username and password of users are we just directly use JavaScript object notion to transfer between the users and server. However, I think it's our responsibility to protect users' privacy. Even we ourselves should not be able to see the password that the users are using. And therefore, to improve it, we should also encrypt the username and password that users use before it was sent to our server. And secondly, it's about the accuracy of our CNN writing recognition system. As you can see in the photo, our recognition system might not be working pretty well sometimes, and I think we need to improve on that point. Moreover, we might also be able to improve our graphic user interface. Since our GUI system is based basically on the Tinker package, many of our designs are limited, especially the button. Maybe in the future we can try to adopt different packages such as PySide. Moreover, there are two more features that we try to implement, but unluckily we do not have enough time to fulfill it. The first one is a feature that allows users to upload their favorite photo as the background of the chatting system. And the second one is we can contain the text in the chat box in bubbles so that it was more user-friendly. Basically, that's all for our final project in ICDS. During this process, we have learned a lot and also struggled a lot. But more importantly, we have discovered that there are still many things that we haven't known yet. We're so glad that we as a team have the opportunity this year to tackle a real life problem by ourselves. And thanks for listening.